The first episode examines how cutting-edge, surface and aerial systems are redefining naval deterrence and operational flexibility. Modern surface combatants are no longer single-role ships. They have become modular command platforms, capable of hosting mission packages that switch rapidly between air defense, long-range strike, and electronic warfare. Vertical launch systems now carry overlapping arrays of interceptors, cruise missiles, and loitering munitions, creating layered defenses able to engage aircraft, incoming missiles, and hostile surface vessels within seconds. Sensor fusion is central. Ship radars, airborne early warning assets, and distributed networks of unmanned aerial vehicles combine to provide a shared, tactical picture, enabling faster, more decisive targeting and reducing the chance of being surprised. Stealthy frigates and destroyers employ signature reduction techniques and advanced decoys that complicate enemy targeting, while integrated electronic attack suites can blind or confuse adversary sensors and communications. Directed energy weapons, including high-energy lasers and high-power microwave systems, are moving from prototypes to operational demonstrations, offering a potentially transformative means of defeating swarms of small boats, loitering munitions, and some missile threats with minimal per-shot cost. In parallel, long-range hypersonic, glide vehicles and boost glide weapons demand complementary defensive measures. The episode explores how layered interceptors, improved tracking radars, and space-based sensors work together to detect and prosecute these fast threats. Logistics innovations also appear: at-sea replenishment, mobile maintenance modules, and modular repair kits shorten downtime and let forward forces sustain operations far from home ports. Training and human-machine teaming are stressed as force multipliers. Advanced simulators, artificial intelligence-assisted decision aids, and autonomous assist systems enable smaller crews to manage complex weapons suites more effectively, while reducing cognitive overload during high-tempo engagements. Cybersecurity and resilient communications are emphasized throughout, because without protected command chains and tamper-resistant data links, even the most advanced sensors and weapons become vulnerable to disruption or deception. The second episode shifts focus to the undersea and unmanned domains that offer stealthy, persistent, and cost-effective options for surveillance and strike. Submarine advancements emphasize quieter propulsion options, improved anechoic coatings, and sophisticated sonar signal processing that increase detection capability while minimizing the platform's own acoustic signature. New families of torpedoes and payloads boast better guidance, countermeasure performance, and modular warheads tailored to anti-ship, anti-submarine, or infrastructure disruption roles. Autonomous underwater vehicles extend the reach of undersea sensing, operating silently to map seabeds, detect enemy movements, and deploy sensors or small weapons where manned platforms would risk exposure. On the surface, unmanned surface vessels and long endurance sea drones can swarm or saturate defenses, gather continuous intelligence, and prosecute asymmetric attacks with deniable attribution and lower cost. Integration matters. When data from satellites, manned aircraft, unmanned drones, and subsurface sensors are fused, commanders gain an unusually clear and persistent maritime picture that complicates adversary maneuvers and shortens decision cycles. Electronic warfare and cyber tools provide non-kinetic means to disrupt targeting, navigation, and logistics, while intelligent mines and remotely reconfigurable defensive fields can adapt to changing traffic and identify hostile signatures to reduce collateral risk. Taken together, these capabilities enable distributed lethality, dispersing offensive punch across many platforms so that striking a single asset yields little strategic effect. Together, these systems form a resilient, multi-domain architecture that complicates any attempt at regional coercion. Forward-deployed carrier and expeditionary strike groups provide visible deterrence, while distributed lethality and long-range fires create denial zones. Autonomous surface and subsurface vehicles extend sensing and targeting. Directed energy and electronic attack options can blunt missile salvos and degrade command networks, and robust logistics, training, and cybersecurity ensure sustained operations. This integrated posture raises the costs of aggression and strengthens collective defense. All of this reinforces deterrence and preserves stability. 3 dives into air and space, capabilities that dramatically enhance maritime dominance and strategic warning. Advanced naval aviation, from carrier-based stealth fighters to long-endurance maritime patrol aircraft, that multiplies reach, giving commanders both rapid strike options and persistent SR. Unmanned aerial systems now perform a wide spectrum of tasks. Tethered sensors for continuous overwatch, long-range UAVs for targeting and battle damage assessment, and small autonomous drones that swarm to overwhelm defenses or relay encrypted data back to fleet nodes. Space assets are increasingly critical. Improved satellite constellations provide resilient communications, high-resolution maritime domain awareness, and early warning of ballistic and hypersonic launches. Integrating space-based sensors with shipborne radars and airborne platforms reduces blind spots and shortens the time from detection to engagement. Air-launched anti-ship weapons and networked standoff munitions extend the reach of sea control, forcing potential adversaries to disperse and conceal valuable assets. Electronic protection suites on aircraft and ships harden platforms against jamming and spoofing, while distributed command architectures allow mission continuity even when individual nodes are degraded. Training emphasizes joint, multi-domain exercises where air, sea, undersea, and space elements rehearse combined tactics and contingency procedures. Autonomy and AI augment targeting cycles and sensor fusion, accelerating threat identification and enabling proportionate responses that reduce collateral risk. Finally, logistics enablers for aviation, forward arming and refueling points, modular maintenance packages, and rapid parts fabrication keep air power effective in contested zones. Episode 4 explores force structure, doctrine, and enabling technologies that ensure sustained deterrence and rapid escalation control. Distributed command and control reduces single points of failure. Mobile C2 nodes, hardened shore facilities, and resilient mesh networks ensure that task forces can operate independently or as a coordinated whole. Doctrine shifts toward layered denial and attrition, long-range fires and sea denial assets, buy time while rapid reaction forces exploit opportunities to shape the battlefield. Investment in resilient supply chains, modular ship designs, and on-demand manufacturing minimizes downtime and accelerates repairs after attrition. Human factors remain central. Socialized training pipelines, AI-assisted decision aids, and cross-domain certifications produce crews capable of operating complex, integrated systems under stress. Electromagnetic maneuver warfare becomes a core element, combining offensive cyber operations, spectrum dominance, and deceptive signaling to complicate adversary targeting and planning. Legal and ethical frameworks for autonomous systems and escalation management are refined to keep human judgment central while leveraging automation for speed and precision. Allied interoperability and combined logistics create force multipliers. Shared basing, cooperative sensor nets, and joint procurement reduce costs and synchronize defensive postures among partners. Finally, deterrence relies on signaling calibrated readiness, forward exercises, visible deployments, and transparent capability announcements that raise uncertainty about the costs of aggression. Redundancy is built into sensing and strike chains. Multiple sensor types track the same target. Multiple shooters can be assigned overlapping engagement zones, and dual-use logistics nodes can shift priorities rapidly in crisis. Investment in realistic synthetic training environments shortens learning curves for new systems and lets commanders rehearse complex, multi-domain kill chains against evolving threat models. Robust cyber defenses and rapid incident response teams protect mission-critical networks and ensure that encrypted links, swarm control protocols, and weapon management systems remain trustworthy under attack. Continual modernization cycles, informed by live experimentation and lessons learned, prevent technological obsolescence and encourage modular upgrades that can be fielded quickly. Taken together, these measures make military coercion costly and unpredictable for any adversary, preserving deterrence while offering flexible options for crisis management and de-escalation. They create resilience, readiness, and strategic advantage worldwide.